Welcome to our lesson on functions and relations. So, to begin, let's talk about a couple of definitions. So, first of all, the definition of a relation. A relation is just two things. Um, so, it's just any set of ordered pairs. Um, they don't really have to conform to any rules or anything. Um, just a set of ordered pairs. Now, when we get into the definition of a function, the definition is that for each value of x in the domain, there is exactly one value of y in the range. So when we're thinking about this, one thing that I like to think about is people and rooms. So we have rooms here, right? Okay, we've got a couple of different rooms. And we've got some people. Okay, well, this person can go into this room. Okay, so this is our people are our domain, and the rooms are our range. And this person can even go into this room. We can have two people in the same room. That makes sense. So we can have two x values that match up with one y value, and that's okay. Now, what we can't have, though, we can't have this first person going into this room and going into this room. That right there, that can't happen because it's just not possible for one person to walk into two separate rooms at the same time. Okay? So when we look at this when it comes to numbers, okay, here we have a 2 and it's matched with a 3. But then we have that same 2 matched with a 4. Well, that doesn't work because the number 2, the value in the domain, cannot map to two different y values. So this is not a function. Now, how about the next one? We have the number 1 mapping to 3. We have the number 2 also mapping to 3. So can two different people go into the same room? They can. And then we have a 3 and a 5, and so that is good. Okay. How about the next one? We have a visual here where -2 is mapping to -2, 6 is mapping to 6, and pi is mapping to pi. So think about this one for just a moment. Is it a function? If you said yes, you are correct. So let's think about these now. So now we have them in this equation function. So think about values of x. Think about different values of x that you could put in here. Each time you put a value of x in there, will it give you a different y value? So try a few. And then in the comments, put your answers to, I want you to try numbers 4 through 8. Think about different values that x could be and are these functions or not? So it is important to know that a function is a relation, okay, where every input has exactly one output. All right. Ordered pairs should be a little bit of a review for you. Ordered pairs can be written as xy. First number is our x coordinate, and the second is our y coordinate. So when we're plotting the points, the point 2, 3, we are going to start at the origin and go 2 spaces to the right and then 3 spaces up. And this right here is the point 2, 3. The point -4, +6, we're going to go -4 in the x direction and +6 in the y. I have to put x's here because if I put dots, it like tries to erase or something like that. And we can plot each one of these. Each one of these is a point on the graph. Some things that we can mess up on is reversing our x and y's. So remember that x comes first and then y all the time in ordered pairs. Okay. In order to find intercepts, we locate where, if we think about the word intercept, okay, if we are thinking about American football or even uh, European football, when we intercept the ball and we're playing, we stop it from moving. We grab it from its original trajectory. So intercepts are where the graph touches or crosses either of the axes. So when we are looking at graphs, we can see that these are points that we touch or cross. In this case, we touch. And so we can see here that our y-intercept, where we touch this y-axis, is at the point 0, 3. And our x-intercept, or where we touch the x-axis, is at the ordered pair 3, 0. Okay? So let's look at this one. We touch or cross here and here, or we cross at all of these places. So this one here, this is where we cross our y-intercept. And that is at the point 0, 4. Now in this particular graph, we have 2 x-intercepts. We cross the x-intercept or the x-axis at 2 separate places. The first one over here is at -2, 0. And then we cross again at +2, 0. Okay. This graph only crosses the axis one time. So we only have a y-intercept here, and that is at the point 0, 3. Now take a moment on this last one and tell me what the x-intercept and y-intercept are. You should notice also that the x-intercept occurs when y equals what? And the y-intercept occurs when x equals what? We can also perform a vertical line test. So the vertical line test tells us that we have a function if any vertical line touches the graph only one time. If the vertical line hits more than one time, it is not a function. So if we think about this first graph, any vertical, that's not a great vertical line, but any vertical line drawn through this graph, if you notice, it's hitting the graph more than once, which makes this not a function. Any vertical line drawn through this graph, if you notice, it's only hitting one time. How about this graph? Is it a function or not? And talking about function notation. So function notation is where we see f of x. This variable inside the parentheses represents the input. Okay? It does not mean that we are multiplying. Okay? So it is not multiplying x by f. Okay? It is the input. So our example is, if we have f of 2, well, what we are going to do, we are going to take this 2 and we are going to input everywhere we see an x. So this is going to become 2 squared minus 3 times 2 plus 2. And we need to remember our order of operations. We do grouping, we do exponents, we do multiplication and division, left to right. We do addition and subtraction, left to right. Okay, so we would end up with 4 minus 6 plus 2, which is going to give us negative 2 plus 2. So f of 2 is 0. Now see what you can do with g of negative 3. See if you can come up with that answer. We can also do this with expressions. So this, remember, inside here is the input. Okay? So we are going to take and input this everywhere we see an x. So the 3 comes along for the ride, and instead of writing x, we're going to put in a plus 1, and then plus 4. Now we can continue to simplify this. And simplify it even more to 3a plus 7.